For this lesson, we're going to continue to explore the multiplication of binomials and polynomials. So the first thing is we're going to take a look at three special cases where if I'm foiling this out, then I'm going to multiply the first terms and get a squared. I'm going to multiply the outside terms and get ab. I'm going to multiply the inside terms and get another AB, and I'm going to multiply the last terms and get b squared. Well, when I combine the like terms here, I get a squared plus 2 times a times b plus b squared. Where I can see the result is first term squared I go to the next example. I'm going to FOIL it out again. A times a gives me a squared again. A times negative b is negative ab. Negative b times a is once again negative ab. And negative b times negative b gives me positive b squared. And I combine the like terms and get a squared minus 2ab plus b squared. The only difference between the first one and the second one was the first one had a plus between the two and the middle term was positive. In the second case, it had a minus between the two terms and the middle term was negative. Beyond that, it's still the exact same. The first term of the trinomial is the first term squared. The last term is the second term squared. And the middle term is the first term times the second term times 2. Let's look at one more case. Here, if I multiply the first terms, I get a squared. Well, it looks the same to start. A times b is going to give me positive ab. Negative b times a gives me negative ab. And negative b and positive b gives me negative b squared. And here I see that I have a positive ab and a negative ab that cancel each other out. When I combine like terms, this gives me a squared minus b squared. Where here I have what is called a difference of squares. I have two perfect squares, a squared and b squared. They're being subtracted from each other. That's where I get the term difference from. And this is the only unique case where if I have a binomial times a binomial, it doesn't wind up being a trinomial. It winds up being just another binomial. The reason for that is it FOILs out the same way all of our other ones did, but because one is positive for the second term and one is negative for the second term, then the middle terms that usually combine together wind up canceling each other out. So, the square of a binomial can be found by squaring the first term, doubling the product of the two terms, and squaring the last term. We've already seen that. The product of the sum and difference of the same two results in a difference of squares. The first term squared minus the second term squared. So I can use that same principle to multiply these out pretty quickly. If I have x plus 7 squared, that's going to be the first term squared. Then the first term times the second term, x times 7 times 2, which would give me 14x. And then the last term squared, 7 times 7 gives me 49. I can do the same thing for example B. 3x and 3x gives me 9x squared. 3x times negative 1 gives me negative 3x, times 2 gives me negative 6x. And negative 1 times negative 1 gives me positive 1. For example C, 2m times 2m is 4m squared. 2m times negative 3n gives me negative 6mn. And I need to multiply that by 2 again, and I get negative 12mn. And negative 3n times negative 3n makes positive 9n squared. For example D, this is where I see a case of that minus and plus again, or like with E, plus and minus. This means that because they're the same values, 4 and 7x, but one is positive, one is negative, it should multiply out to make a binomial. So then I would take the first one squared, 4 squared is 16, and subtract from that the second one squared, 7x squared is going to be 49x squareds. Same principle for E. One's positive, one's negative, so 5a times 5a gives me 25a squareds. And positive 3b and negative 3b makes negative 9b squared. Sorry about that. For E, they are both negative, so it's not going to be a difference of squares. It's going to be like one of these trinomials. And I'm still going to do the same process. This is the same as 2p minus 9q squared. So I'm going to square the first term, 4p squareds. I'm going to take the 2p times the negative 9q, or get negative 18pq, and then times that by 2 again, and get negative 36pqs. And negative 9q times negative 9q gives me positive 81q squareds. Okay, so now, what if we have three things we're multiplying together? Well, the problem is there's a misconception when we see these. People see the 5 on the outside and say, okay, well, I need to multiply the 5 into here, and I need to multiply the 5 into here. But that's not actually true. If you think of a more simple one, if you said that you had 5 times 2 times 3, well, typically, we just multiply two of the terms together, and then take that resulting multiplication and multiply that by the third term. We're not going to multiply 5 times 2 and 5 times 3 and then take the 10 and 15 and multiply those together. That number isn't going to work at all. Well, it's the same thing with these, where I'm just going to take two of the things that are multiplied together, I'm going to expand them out and combine them, and then I'm going to multiply whatever the result of that is by the other thing I'm multiplying. Typically, and you don't have to do it in this order, typically I do this based on the most complex multiplication going to the easiest multiplication. So typically what I would do is I would multiply out just the binomials first, knowing that whatever the result of that is, I'm going to multiply that by 5. So I'm going to expand this out, and when I multiply it out, I get 2x squared minus 12x minus 3x plus 18. I'm going to combine the middle terms so I have less multiplications to do, and I get 5 times 2x squared minus 15x plus 18. And then, knowing my distributive property, I'm going to multiply that 5 into all three terms of this trinomial. So in the end, what I have is 10x squared minus 75x plus 90. If I use the same principle for the second one, I'm going to do the same thing. I'm going to square the 7p plus 3 before I multiply it by the negative 8. So I'm going to leave the negative 8 on the outside, put in brackets, and then expand this out. Well, if this is squared, then it's going to be the first term squared. It's going to be the 7p times 3 times 2, and it's going to be the last term squared. And now I can multiply the negative 8 into all three parts here. I have negative 392p squareds minus 336p minus 72.